Hello and welcome back to Ganesh Institute. In today's video, this is another video on graph theory. We are going to talk about various types of graph, okay? So first up, bipartite graph. What do we mean by bipartite? Now, as the name suggests, it has bi, that is two, and partite means partition, okay? So let's say if I'm having, there are two sets, X and Y, okay? These two sets are the subset of a set having vertices only, okay? So there is a graph and a set of vertices is represented by VG. For example, if I'm having this graph having vertices V1, V2, V3, and if I create a set out of these three, so V1, V2, V3 will be our set of vertices, okay? VG. So let's say I'm having two other sets, but these are the subsets of this vertices set, okay? Now what happens? How can I say that a particular graph G is a bipartite graph? Only if I'm having this condition, XY is a subset of VG, and every edge in G, if I'm having the edges, for example, this one E1, every edge in G has one endpoint in X and the other endpoint in Y. What does it mean? Let's say I'm having these three vertices A, B, C, and then this is connected with D, E, F. I'm having D here, D, E, and F, okay? Now, A is connected with E, D is connected with B, B is connected with F, and D is again connected with C. Is it okay? Just a graph, any random graph. Now, what is happening? If I tell you that I'm having a set of vertices A, B, C as X and set of vertices Y, the vertices are D, E, F. Tell me what is the common if I ask you intersection of X and Y. What is common in X and Y? You can see A, B, C, D, E, F. Nothing is common. So it is phi, an empty set if we talk about the intersection. So we can say that these X and Y are partite sets. Okay? Because they don't have anything common. If I talk about the edges, so every edge in G has one endpoint in X and another one is in Y, okay? Then we can say this is Y, okay? Then we can say that this is a bipartite graph. Is it fine? Nothing common. Edges formed. For example, this edge, AE. A vertex is from another set and E vertex is from another set. DC. D is from another set, C is from another set. So these are forming a bipartite graph, okay? Then we have a complete bipartite. Complete bipartite graph. Here what we have, every vertex of one partite, for example, here, every vertex of one partite set is connected, okay, is adjacent to other partite set. It has to be adjacent, okay? Every vertex of one point of one partite set has to be adjacent to the other partite set. Then we can say that it is complete bipartite. For example, let me say every vertex of one partite set is adjacent to other partite. What do we mean by adjacent? For example, V1, V2, V3. So these two edges are adjacent. Okay. Now V1 is adjacent to V2 vertex. V1 is adjacent to V3 vertex. Okay. So every vertex, if every vertex here, only V1 is adjacent to both V2, V3. So we cannot say that it is a complete bipartite. Okay. Every vertex has to be adjacent to another one. Can you think of any example? Do comment in the section. Okay, next is directed graph. Directed graph is also known as digraph. Now, as the name suggests, directed means it must be having directions, right? For example, if I'm saying I'm at this point V1, I move to V2 and then V3. From V2 I went to V4. Okay, I have written here, this is 2 units, this is 5 units, this is 6 units. If I have marked the direction that V1 to V3, V1 to V2, V1 is my source point, V2 and V3 are destinations. Then again from V2 to V4, because arrows are given here, directions are given, okay? And so this is a directed graph. Also, because weights are given, the units, the distance or cost or something, some weight function is given. So we can also call it as weighted graph. What is it called? Weighted graph. Okay. Then we have equal graphs. Equal graphs means, see, graph is made up of two things, vertices and edges. So if I'm saying that two graphs, G and H are two graphs, and these are equal, then their vertices and edges have to be equal. EG should be equal to EH, edge of graph G, edge of graph H should be equal, and then we have vertices. What the set having all the vertices of G must be equal to set of having vertices of H. Okay. Then there is subgraph. Subgraph. Just like a subset, here, let's say I'm having two graphs, H and G. If I want to say that H is a subgraph of G, that means the set of vertices of G must be greater. Okay, so set of vertices should be a superset, and set of vertices of H has to be subset or equal to VG. Edges, again for H, because it is a small set, I want to prove it as a subgraph. So its edges, the set of edges has to be a subset or equal to the set of edges in G. Okay. So this is a subgraph. Then comes spanning subgraph. What is it? Spanning subgraph. Here we already have H as subgraph of G, but if I'm having this condition, H is a subgraph, that means it is understood that vertices of H is a subset of vertices of G set, and edges of H is a subset of edges of G. But the only extra condition which makes it different from subgraph is vertices are exactly equal. They have to be equal. Then only we can say that it is a spanning subgraph. Not only the subset, but the equality should be there. Okay. Then we have induced graph. Induced subgraph. Are we on the same page? Everyone, please pay attention here. So, induced subgraph means, let's say I have a subgraph H1. Subgraph means it is a subset of G or equal to. If I'm having H1 and it has all the edges. It contains all the edges in G. Okay, all the edges of H1 are in G. Edges have to be there. And that too, of course, they will be in G because it is a subset. So if I am saying edges of H, this is a condition. What is new in it? But the new condition is those have to be between every pair of vertices. Okay? Between every pair of vertices of H1. Tell me the example. Can you draw such subgraph where you are having some of the vertices here, H1, and some of the vertices in G such that both H1 is the subgraph. And now you are seeing that every edge which is there in H1 is lying between the pair of vertices of H1. Is it possible? Tell me. Great. So this is the type of graphs which we have got. We will take this discussion further in our next videos. Till then, take care of yourself and don't forget to like, share and subscribe our channel. Bye-bye.